Dear students, so in this lecture we are going to discuss about the what is a deep learning, right? So where the actual deep learning journey is started. So before going to discuss actual content of today lecture, we are going to discuss of outline of today presentation. So that is like what is a neural network. We will discuss first what is a neural network, then what is a actual neuron. What is a neuron? So basic building block of neuron. Then we will discuss how to learn the neural networks. That means that how the neural networks are learning. Why neural networks and architectures of from some of the basic architectures of the neural network we will discuss, and at the end we will discuss about applications or future trends of neural network. Right. So first of all, what is a neural network? What is the inspiration? So what is a neural network means? So it is a simple. So it is neural network means it is mimic the human brain. How the human brains are functioning, right? So for example, take the human brain normal scenario, right? So if we touch any hard object, right, with our hand, right, so immediately we pull back to the our hand. It means that the what is the hardness we are feeling at the fingers, and that signal will be sent to the brain. The brain will process what type of action need to be taken with the hand. So those kind of architecture is a neural network, right? So neural network is simple idea. It is exactly mimicking of our brain, right? So as a normal humans composed with the interconnected neurons. That means that just now we discussed hands neurons are connected with the backbone neural networks. So backbone connected to the brain neurons, like that. So information will be passed from one end to the another end, right? At same time, it is ability to learn the data and identify the patterns. So that means that as a human being, it is able to learn its own and able to identify the patterns into the data. So without explicit program, it means that there is no explicit programming is required to learn the patterns from the data. So this is the second point. Third point, so based on these neurons, as a foundation for the modern AI and deep learning, right? So this is about the foundation stone for the neural network, right? So simple we can say, visual idea you can see, right? So comparing the biological neuron with the artificial neuron image of the human brain. So that means that, so we can see the diagram. So human brain is like this. So actually data is flowing like mimicking the human brain from one point to the another point. So this is a one kind of neuron, this is a one kind of neuron. These all are the some processing elements. You can say simply how it is data is processing from one end to the another end. So we will discuss how it is actually single neurons is processing, and after some classes we are going to discuss about more details, right? So now, so what are the basic building blocks of deep learning, right? So that is a neuron, or we can say it is a perceptron. So that means that what is the actual building block for deep learning. So that is a simple funda, it is a neuron, right? So what is the actual artificial neuron? So artificial neuron, we can see the diagram in this figure, right? So x0, x1, x2, x4, so on, xn, it is a inputs. So whereas a w1, w2 up to wn, it is a some weights. So we have to calculate the sum function, that is a weighted sum. It may be the any function like summation or a maximum or whatever it may be, right? So that function is a weighted sum. We are taking weighted sum. Function is a activation function. So that means that whatever data is coming here, so that data should activate the neuron and send the information to the further layers or not. So this is a simple idea, right? So for example, take the input. Input is a x1, x2 up to so on xn. So these are the outputs from the previous. So that means that if you take this is the x component, so there will be one more x1 component and one more x0 component, which comprises of input, weights, weighted sum, activation function and output. So that means that sequentially one neurons is connected with each and other, so that entire neural network architecture will be formed. So weight is a strength of connection. So it's simple, it is some data point, but it may be 0 or 1, something like that. So weight is a strength of connection learned during training. What is a training and all those things we will discuss at the after few lectures, right? So strength means, for example, x0 is a data point which is importance of 0.6. So x2 is a data point which is a strength of 0.1. So that means that indirectly we can say the importance of the input. So next is a bias. Bias is a additional input, right? It allows the activation function to shifted. So that means that its activation function, it is allowing activation function some of the external input, so which will activate or not, right? So function one, next one is a summation function. Summation function we can take weighted sum of the all inputs plus bias. So bias also included in this one, right? So these are the summation function. It may take anything. Activation function, it is introducing the non-linearity. So there is a different activation functions are present. So that is the like sigmoid activation function, ReLU activation function, TANH activation function, right? Leaky ReLU. There are many activation functions are present. It depends on our requirement. We are going to use the activation function, right? So we are further classes we will discuss the what is the this specific uses. For right now, you remember there is a some activation function which will activate the data to pass to the next neuron or not. So visual idea you can see here. So just now we discuss about this one, right? So next how neural networks are learned, right? So it is a learn two steps. So that is a forward propagation and back propagation. So forward propagation means data, input data passes to the network to the produce the output. So that means the data is passing from this end to the this end, phases by phase, like one phase, second phase, like something like that. So at the end it will give an output, right? So last means whatever the actual output need to become. For example, output is need to become 90, but you got output as 80 only. Just I am giving simple example. There is no such kind of numerical values in deep learning, but as per better understanding I am giving. So what is the need to become? Actually 90 should come, but what it came? 80 came. So what is the loss? Loss is a 10 by 90. So it will come approximately 11%, right? So this is the loss percentage. So to calculate the loss percentage, there is a different measures. So that is a mean square error, cross entropy error. So about all these things we will discuss into the further classes. But you remember there is a loss function. It will measure the difference between the actual output and target output. right? So back propagation. So that means that what is the back propagation? Just now we discussed error is approximately 11%, but we are not able to tolerate the 11% error. So in that case, what we will do? Error will be back propagated to the output layer, to the previous layer, and their previous layer, then previous layer. So in that layer, it is going to the till the first layer. So in the first layer, the neuron will be that neurons weights will be get adjusted, and it again learn from forward propagation from starting point to the ending point, right? So this is the back propagation strategy. That means that if error is came, it come to the back, and it is going to the again learn from forward and again backward, again forward till the point is reached, right? Next one is optimization algorithm. So what is the optimization? So that means that here it is a loss is came 11%. So to minimize the loss, there is some different algorithms are there how to optimize this loss. So that is a gradient descent is one of the algorithm. So there are different algorithm. So we will discuss more details into the further classes. So approach. So what is the approach? One pull pass from training data through the networks. So that means that what is the input is taking, what is the output is given. So this is about one full approach. So at the end we will discuss one of the practical example of further classes, so that you will understand more clear. So why neural networks? Why you need to study the neural networks? So what is the power of neural networks? So it will recognize the pattern recognize. We are going to use the neural networks, and there will be one of the advantage adaptability and learning. So that means that these neural networks we can adapt any of the area, and same time it is a learning. So that means that new data it will learn without explicit programming, right? So this is the one of the advantage. So next one is handling non-linearities. Activation functions so enable the model complex non-linear relationship. So that means that it is a complex function and non-linear relationship also it is able to learn easily. So this is one of the advantage. Feature extraction. So those who are having machine learning idea, so they might already know what is a feature extraction. So in a machine learning, feature extraction will be done on a manual basis, but whereas a deep learning, it automatically extract the features from the raw data, right? So this is the one of the beauty of the deep learning, right? Scalability. So what is the scalability? Scalability means it can extend the very complex problem and massive data sets. That means that if your data set size is also increase more and more, so there is no performance degradation. So this is the one of the advantage. Performance also it is better as compared to the machine learning algorithm. So this is the neural network benefits. So next, neural network architectures. So there is a different kinds of neural network architectures. We will learn one by one, right? So first one is a neural network architecture. So key point is different problems require different structure. So that means that we at the starting of this class we discuss about the neural network input, right? So what is the input you are providing depends on that input data, like numerical values or image value or structured data or unstructured data or semi-structured data, depends on the data which you are providing to the neural network. There is a different neural network architectures are suitable. So for that we are going to learn the different neural network architectures, right? So that will be connectivity layers, information flows, that will be depends on a neural network architecture. So there will be feed-forward neural network, or we can say multi-layer perceptron, and one more is a convolutional neural network, CNNs. Next one is a RNN, recurrent neural network. Any other architectures also we are going to learn, right? So first one, feedforward neural network or multi-layer perceptron. As like we discussed, there is an input layer and there is some hidden processing layers. There will be some output layer, not some, only one output. So right, so input layer and there will be different hidden layers. So this is about a brief introduction about feedforward neural network. So input layer, what it will do? Input layer receive the raw data, right? From the raw data, it is a hidden layer. There will be one or more hidden layers. So from that input data, the hidden layers will take the input and it will be processed. So and there will be in different hidden layers, like so those hidden layers will be connected to each other. So data which is processed to the hidden layer 1, it will be passed to the hidden layer 2. So like that it is going to be processed, right? So output layer produce the final output. So either maybe in the prediction or classification, right? So this is about a brief introduction about multi-layer perceptron or feedforward neural network. So one of the information is flow in a unidirectional. So that means that data is passing from one direction to the other direction, not backward direction. So that's the way they call it as feedforward neural network. So where we can use this one, like image classification, regression, natural language processing, fraud detection, etc. We are going to use these kind of multi-layer perceptron or feedforward neural network, right? So next one, CNN. So it is a convolutional neural network, right? So in a convolutional neural network, we can see here data, input data, and there will be convolution, and there will be a pooling operation, fully connected layer. There will be the output, right? So it is designed for image and video processing. So image and video processing, it is a structured data. Image, we can say simply it is a array. Those who are known about images, they might understand clearly, but those who are new fellows, they might face some difficulty. Image means simple. It is a array. It is collection of rows and columns. What are video? Video is a collection of frames. What is a frame? Frame is a some number of images, like 32 images per frame, or 12 images per frame, 16, something like that, right? So convolution means it will apply some filter kernel to the input layer to detect the features. So that features may be edges, textures and shape or something. For example, if you take the image of home, right? So in a home there will be some compound, a wall, or there may be some garden, all these things. So walls detection and compound wall, these are some of the features, right? So we will discuss features in a more detail when a convolution will study at a more detail. That time we will discuss. Pooling means so reduce the spatial dimension. For example, this is the image, right? For example, take this is the image 1, 2, 3, 4. So pooling means it will reduce the dimensionality to the 4 by 4 to maybe 1 or maybe 2, something like that. So there will be different pooling techniques are there. That is the max pooling, average pooling, like mean pooling. So there are different. So when you are studying in the CNN, you will able to understand more details. So fully connected, next one, fully connected layer. Fully connected layer at the we will use the traditional feedforward neural network at the end of the classification or regression. So that means that here it is previously we seen feedforward network. This one is a, we can say, fully connected layers. So each and every neuron will connect to the all remaining neurons into the next layers. So in that way we are going to choose the fully connected layer, right? So advantage is spatial hierarchy, so parameter sharing. So what is the parameter sharing and spatial hierarchy? So we are going to learn more details in further classes, but remember what is the convol? There is a architecture CNN which is used for image and video processing, right? So next use cases where we can use image recognition, object detection, facial recognition, medical image analysis. We are going to use this one. Next one is a recurrent neural network. So in this one we use the sequential data. So whereas a previous one CNN is used for structured data, whereas a RNN is used for sequential data like time series data, time series and natural language processing. These are the one of the example for sequential data, right? So what is the key feature? It is having some internal memory allowing them to process in sequential manner. For example, we are speaking about, so word which is coming now and word which is coming before, there is a some connection with respect to the time. So that kind of, for example, we have cat, eat, rat. Just I am giving example. Just don't think about syntax and all grammatical mistake. Just I am writing. For example, if I write simple eat, there will having very less meaning. If I join with cat, so cat is a word which is coming before 8. So that means that this full sentence going to form the new meaning. So that means that with respect to time, each word having some specific meaning with respect to the time, right? So that's kind of data analysis we are going to use the RNN, right? Hidden state, it will carry the information to the next step, right? For example, this you take the input data. So this is the hidden layers. So data which is processing from here, so it is carried forward to the here and like that it will go, right? So which the output is coming, that output will be coming to the previous layer and again it will be started. So it is looking like back propagation, but it is not at all actual back propagation. So which example is speech recognition, machine translation, natural language processing, stock price prediction. So next one is some other novel architectures, right? LSTM, long short term memory, LSTM. So it is a specialized RNN. So that means that RNN one of the novel architecture. So it is a designed for vanishing, to avoid vanishing gradient problem. So we will discuss what is a vanishing gradient problem at the time of neural network training. So one of the GI network of RNN also GRU. It is a simpler variation of LSTM, right? So next one is a generative adversarial networks. So GAN. So we can generate an adversarial network. So what it will do? It will having two networks. One is a generator network. One is a discriminator network. So what will do generator network is it will generate the images, whereas a discriminator is able to identify the whether it is a generated image or original image. So that means that there will be real images. So that real images neural network will learn, and generator network will generate the new image, right? So that real image and new image will pass it to the discriminator, right? So this discriminator job is to identify whether it is a discriminated one or original one, right? So this is about brief introduction related to the GAN, right? So next one is a transformer. So it is a revolutionary from NLP, natural language processing, so which is a more advanced as compared to the RNN. So it is having self-attention mechanism and explicit parallel processing. So if you better understanding with RNN, and you can able to understand the transformer, otherwise you will face a difficulty to understand what is a transformer, right? So we will discuss at the time of some more detail in further classes. There we will discuss more details about the transformer. So applications of the neural networks is a computer vision, like self-driving cars, image classification, object detection, facial recognition. These things we are going to discuss about the use the neural networks. So natural language processing, like when you are speaking, so everyone, as of my knowledge, everyone using a smartphone or smart devices. Like, so when you are speaking, it is able to recognize your voice and automatically it will process. So that is a machine translation, some kind of stuff in a NLP. Also, we are going to use either maybe text generation, chatbots, etc. There are many applications, but few are listed. Speech recognition, just now I discussed. Healthcare, like disease diagnosis, drug discovery, personal image, etc. Finance, like fraud detection, gaming, etc. There are many applications for neural networks, right? So, so there will be like this deep learning algorithm hardware. There is a continuous advancements in GPU and TPU, right? So it is that DL is integrated with the everyday life, right? So now they are focusing on more on ethical consideration. That means that explainable AI is a future consideration. Hybrid models also different AI techniques. So potential solving it is a DL having potentials to solve any complex and global real world challenges, right? So now I come to the end of the today class, which is a deep learning introduction, right? So if anyone having any queries, you may write in a comments box, right? So thank you for watching. If you like my content, please like my video, share to your peers and needy people. So thank you for watching.